Hi everyone, welcome to ICP Desk webinar today. This is Joyce from ICP Desk International Sales and Marketing Division. I will share how ICP Desk Smart Transportation Solutions help you connect everyday journeys. In this webinar, 5 case studies are prepared for you, including a reliable data transmission solution for charging piles, the cloud management solution for ensuring underpass safety, the GPS fleet management solution for recreation areas, the traffic flow monitoring on highways, and the railroad switch monitoring solution. First, let's have a look at the reliable data transmission solution for charging piles. In South Korea, the government aims for nationwide installations of 300,000 to 400,000 electric vehicle charging piles in 3 years. With such a plan, the renewable energy market centered around charging piles, electric vehicles, and green power has drawn people's attention. In this case study, the customer is a well-known charging pile supplier in South Korea, where EV charging stations are scattered across. Maintenance personnel had to shuttle constantly between locations for equipment status checks, which was laborious and cost a lot of money. The customer thus adopts ICP Desk EV charging pile monitoring solution to reduce the cost involved and efficiently deploy human resources. With the solution, maintenance personnel can remotely monitor each charging station's status in real time. The data is transmitted through fiber optics and is susceptible to electromagnetic interferences, eliminating disturbances caused by electromagnetic fields generated by high currents used in charging piles, and extending the communication distance. So, why did people develop CAN bus? Previously, automotive manufacturers used dedicated wiring, leading to bulky and expensive wiring. In the 1980s, CAN bus was developed by Bosch for in-vehicle networks to reduce cost, complexity, and weight. After that, it is not only widely used for automobile communications, but also becomes a standard for industrial communication. CAN bus, the Controller Area Network Bus, is a high-integrity serial bus system for networking intelligent devices. It is a simple and low-cost system that reduces the overall harness weight and amount of wiring needed. CAN bus is a broadcast type of bus. Messages are broadcasted to the entire network, and each device can decide to receive or filter a specific message. Every message is assigned a priority level. If two nodes try to send messages at the same time, the one with higher priority will be transmitted first, making the communication smooth. In addition, CAN is highly reliable, even in extremely noisy environments. It can detect data errors and remove a more functional device from the CAN network. This error confinement mechanism prevents more functional devices from disturbing the overall network traffic. In this case, the data on the EV charging pile status is transmitted to ICP Desk I2533 CAN to multimode fiber bridge through the CAN bus and sent to another I2533 module via fiber optics. Subsequently, the data is transmitted to the central controller using CAN bus again. This solution extends the communication distance and avoids electromagnetic interferences using fiber optics and achieves reliable remote monitoring. The I2533 module allows bow rate configuration via a rotary switch. With the easy-to-use message filter function, it enables smooth data exchange between two CAN networks using different CAN baud rates. The module can connect up to 100 CAN nodes. The communication distance of fiber optics can reach up to 2 kilometers, unaffected by the baud rate on the CAN network. The broken line detection function for fiber optics is also supported. The second case study is the cloud management solution for ensuring underpass safety. In summer, flooding is often reported in Taiwan due to heavy rains and typhoons, especially in low-lying underpasses and tunnels. Accidents happen when cars accidentally drive into and get trapped. In order to ensure the safety of underpasses, ICP DAS offers a complete cloud monitoring solution. ICP DAS liquid probe is used to detect the water level in the underpass, and the liquid leak detection module transmits the resistance value to the Y series edge controller. When the water level exceeds the set threshold value, a warning message will be displayed on the ICANN LED display. Meanwhile, the boom barrier will be lowered to prohibit the passage of vehicles while activating drainage pumps using power relay modules. The control center's computer is equipped with ICP DAS IIoT Cloud Management Software IoT Star to monitor the water level information on site in real time. IoT Star helps users quickly establish a dashboard without the need for programming. The software simplifies system setup through a web-based interface, significantly reducing costs for development. In addition, we can also install alarm siren modules and IP cameras to other road users, making the entire cloud-based monitoring solution more comprehensive. When the underground tunnel is flooded, WISE Edge Controller activates IP cameras to capture on-site images in real time and send them back to the control center. This allows management personnel to receive on-site information immediately and take action as needed. ICP DAS liquid leakage monitoring modules are a combination of ISN series I/O modules and the CALLD series liquid leakage detection sensors. For the I/O modules, we offer 3 product series, including the ISN 101, ISN 104, and ISN 104E series. All the product series support the detection distance up to 500 meters. The ISN 101 series is a one-channel module, supporting DCON and Modbus RTU protocols. In addition, when a liquid leak is detected, it can trigger alarms through the relay output to notify the on-site personnel. The ISN 104 and 104E series modules provide 4 channels that can connect with 4 detection sensors. Users can install the sensors in different areas for liquid leakage detection. The difference between these 2 modules is the protocols they support. The ISN 104 module supports DCON and Modbus RTU, while ISN 104E supports Modbus TCP protocol. As for sensors, ICP DAS offers 2 types of leakage detection sensors, the detection probe and detection cable. Both sensors should be used with ICP DAS ISN series I/O modules. The liquid leakage detection probe is designed to detect liquid leakage at a specific location or water level. For example, the water level in underground mines. On the other hand, the liquid leakage detection cable can detect leaks over large areas. For example, the liquid leakage in data centers. Users can choose different sensors according to their needs. The TM series I/O modules, in this case, activate boom barriers and trigger drainage pumps as needed. ICP DAS Y series Edge Controller provides an easy-to-use web interface. Users can finish the setup without the need for programming. A standout feature of the Y series edge controller lies in its if-then-else statement capability. In this case, when a flood occurs, no matter whether the Y series is connected to the monitoring software in the control center, it can activate boom barriers and pump motors promptly through the if-then-else statement. At the same time, it can send other messages via email, Line, WeChat, and SMS. The built-in data logger within the Y series provides a data recovery mechanism. When a network outage occurs, the data will be stored in the data logger temporarily. After the network resumes, the Y series will transmit the stored data to the control center again. This avoids data loss. Moreover, it supports multiple cloud platforms, including Microsoft Azure and IBM Bluemix. The IoT Star cloud management software provides 2 basic functions and 3 optional functions. The remote access service enables users to update the firmware for the connected controllers, and the sensor data service can log the collected data in cloud database, including MySQL, SQL Server, and Oracle. Optional functions include the dashboard service, report service that can export PDF and Excel files, and Line bot service that enables users to use Line app to query and monitor sensor data. The third case study is the GPS fleet management solution in recreation areas. In order to protect the environment and achieve the goal of eco-friendly tours, Taiwan's most famous and popular forest recreation area, the Alishan National Forest Recreation Area, uses electric buses to provide transportation services in the park. However, its high altitude with a very high level of humidity lowers the mileage and battery lifespan of electric buses. Therefore, the control center hopes to effectively monitor the charging and the aging processes of batteries, the driving distance, locations, and battery levels of electric buses. The solution structure is divided into 2 parts: the electric bus fleet and the control center. The M7018RG 8-channel thermocouple input module and the M7017 RA5G 8-channel high-voltage I/O module collect battery temperature and voltage from the electric bus fleet and transmit it to the GTP541M series remote controller. The GTP541M can obtain real-time location data of the electric buses via GPS and then transmit this information together with battery and traffic status to the control center via 3G or 4G. In the control center, a Viva Edge SCADA can display information on the dashboard and perform data analysis. Also, data can be stored in database for further use. The M7000 series I/O modules support digital and analog input-output channels. To cater to diverse application needs, the modules provide voltage, current, and different sensor inputs. In addition, it provides the dual watchdog function. The module watchdog will automatically reset the microprocessor when the module itself malfunctions, while the host watchdog ensures smooth communication between the master and I/O modules. Management personnel can preset a safe value so that the module switch to a safe output state when it cannot receive a command from the master within the preset time. The power on value ensures the module starts in a predefined output state when powered up or restored after power loss, enhancing the system reliability. The I/O modules are further fortified with ESD protection and 3000 VDC isolation to keep everything secure. The fourth case study is the traffic flow monitoring solution on highways. To relieve the traffic congestion on National Highway No. 4 in Taiwan, the government installed inductive loops as vehicle detector to measure various traffic parameters. In combination with the sensors, the government used the traffic flow monitoring solution provided by ICP DAS to collect, control, and analyze a large amount of real-time traffic information. In this case, ICP DAS IP8441 Programmable Automation Controller, I8053WA1G Digital Input Module, and I8057WG Digital Output Module are used to monitor the traffic flow and vehicle speed collected by the inductive loops and remotely control traffic signals and switches. In this case, the IP8441 pack plays an important role in traffic flow monitoring, remote control and monitoring of traffic signals and switches. It provides road users with various information, such as road conditions or real-time traffic information. The module supports various communication interfaces, including Ethernet, RS-232, and RS-485. In this case, it transmits the on-site data to the control center using Ethernet interface. Besides, it's equipped with 4 I/O expansion slots for various applications. The I8000 series digital input modules are the I/O expansion modules for ICP DAS programmable automation controllers. In this case, the I8053WA1G DI module provides 16 channels to collect signals from the inductive loop detectors. With the photocouple isolation protection, it avoids interferences during data collection and transmission. The I8057WG DO module provides 16 channels to trigger traffic signals and switches remotely, which reduces the need for additional labors. Furthermore, the module provides ESD protection and intra-module isolation protection for communication safety. ICP DAS provides various I/O expansion modules equipped with 2 different types of I/O communication buses, including parallel bus and serial bus. The I8000 series, the parallel bus type, are high-speed ones that can only be used with ICP DAS packs. The I87000 series, the serial bus type, are low-speed ones that can be used with ICP DAS packs and I/O expansion units. The last application story is the railroad switch monitoring. In rail transport, railroad switch plays an important role in ensuring trains move in the right direction. Usually, the control center is responsible for controlling the movement of the switch through the side panel, so that the train can move on the correct track. To ensure the smooth operation of railroad switches, Taoyuan Metro in Taiwan adopts ICP DAS solution to monitor the status of the switches. This solution collects the switch data and provides alarm, data analysis, and storage functions. This keeps the management personnel updated on the overall situation and can implement instant controls, preventive maintenance, or equipment replacement. This solution can be divided into 2 parts, the railroad tracks and the control center. On the railroad tracks, ICP DAS I8017HWG AI module, I8046WG DI module, and I8064WG power relay module collect current, voltage, operating time, and locations of switch motors. Then the data obtained are sent to the programmable automation controller. In the control center, a Viva H SCADA displays the real-time data on dashboard, including current, voltage, and power waveforms of each switch and the connection status of each station. The WP8821CE7 A-slot pack has excellent real-time data processing performance. In this case, it performs as the data logger to store the data of current, voltage, location, and calling signals of switch machines. In addition to data logging, it can also calculate the operating time of the railroad switches. At the same time, the module transmits the on-site data to the rail control center through the Modbus TCP communication protocol. The I-8046WG 16-channel digital input module collects forward and reverse signals of the switch machines and captures the track positional signal. This module is suitable for long-distance measurement. The effective distance for dry contact connection is up to 500 meters. The I-8017HWG obtains the voltage and current data of switch machines. The I-8064WG 8-channel power relay module can trigger alarms to indicate abnormal situations when critical data goes beyond the preset threshold parameters. ICP provides holistic product lines, including I/O modules, sensors, intelligent controllers, display panels, and many more products. By integrating them into transportation system applications, we help ensure safety and enhance efficiency in transportation systems. Aside from the smart transportation solutions, we also provide lots of solutions that can be applied in different fields, including factories. ICP implements digital transformation in conventional factories with harsh environments, reducing human errors during manual monitoring processes. This facilitates remote access to real-time equipment data, or calculating availability, enables predictive maintenance, and optimizes production processes. For more details of the success stories in factories, please stay tuned for ICP webinar in May. Thank you for participating in our webinar today. Don't forget to scan the QR code and complete the questionnaire. We will send you this PowerPoint file after you complete it. Now, we're moving into the QA section with Kevin. If you have any questions, please feel free to ask.